Hi everyone, welcome to lesson 1 in our very first unit. Today is going to be a bit more of probably a recap for most of you. It's going kind of through some of the grade 10 and grade 11 material. But if you are struggling with whatever we go through today, please don't hesitate to reach out. I have zero problem helping. So the things we're going to cover today are unit conversions, perimeter, area, and the Pythagorean theorem. So if you have not done so already, what I would recommend you doing is going and downloading this conversion chart. So this is going to be lovely for you guys to use while you're doing the homework. And it's also going to make things a lot easier for you. So what it does is it tells you the conversions, obviously. So if we take a look up here, so for every 1 mile, it's 1,760 yards. For every 1 yard, there's 3 feet. It just makes conversions a lot easier versus Googling all of them. So let's get into our examples. So this, I don't know if you guys have learned this way, but this is the way that I've learned to do unit conversions. This is the formula I've used previously. It looks scary. I promise you it's not. It allows us to get the new units fairly easily. So we always take the old units and you multiply it by this division looking thing. So it's the conversions of your new units go on the top and the conversion of your old units go on the bottom. Right, so let's take a look at our first example. So convert 25 centimeters into inches. Okay, so the first thing I need to do is to look at what I have, right? So that's my starting units. So let me just get a pen going here. So my starting units are 25 centimeters, right? So I would put, or centimeters, so I would put 25 centimeters here. And then that's the value of my old units, right? And then I multiply. And I now have to figure out what do I want. So what I want is inches, right? So I have to go see what the conversion is from centimeters to inches. So I go back to my conversion chart and I take a look, and it's for every 1 inch, there's 2.54 centimeters. So I go back over here and I would put just up here for my brain, 1 inch equals 2.54 centimeters. So I take a look and I know that my new units go on the top, right? So my new units is going to be my inches. So I'm going to put 1 inch on the top. And then my old units go on the bottom. So my old units is centimeters because that's what I want to get rid of, right? So I'm going to put 2.54 centimeters on the bottom and then put an equal sign. So from here, I can actually cancel out my centimeters because I have centimeters being multiplied up here and centimeters being divided down here, so they can actually cross out. And so what I would do is I would do 25 times 1 divided by 2.54 centimeters, which is actually going to give me 10 inches. And then that would be my answer. So I would box my answer. And guys, please, 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 if you ever do hand anything in, box your answers. It's so much easier for me to see, and it forces me to look straight at your answer from the very beginning. More or less, it's just easier for me to see. So let's take a look at our example 2. So I want you to convert from 6 kilometers into miles, right? And we're going to use the same steps we just did. So what do I have for my starting units? I have 4 kilometers for my starting units, right? So I'm going to go 4 kilometers and then a multiply sign and then get this set up here. So I now need to figure out, what do I want? Well, it's already here. I want miles, right? So I have to go back to my conversion chart and I take a look at where kilometers to miles is. So if I take a look over here, right, I have 1 mile equals 1.609 kilometers. 09, sorry. So I come back down here and I go, I would put this up here, 1 mile, just for my own brain, equals 1.609 kilometers, right? And so I take a look at my formula and I put my new units on the top and my old units on the bottom, right? Because we want the units to be able to cross out. So I would put my new units on the top. So my new units is my miles. So I have 1 mile on the top. And then my old units is kilometers. So I would go 1.609 kilometers. And what you can do is do this first. So I would do 1 mile divided by 1.609 kilometers. And then I would take whatever that is and multiply it by 4 kilometers. So let me just get my calculator up here. So I would go 4 times whatever that 1.609. And I get, because these can cross out, right, my kilometers and my kilometers, so I end with miles. So I get I'm just going to round up here, 2.5 miles. So in 4 kilometers, I have 2.5 miles. That's my answer. So I do have one where you can try it here on your own. So I want you to convert, 4.1148 meters into yards. So this is the answer that you should get if you want to pause it and try it on your own. Otherwise, you can continue listening, and we're going to actually head on to perimeter and area. So what I want you guys to do is I actually have this up for you already. So you can print it off if you want. I mean, you can also probably find a filled out one online, but I'm going to fill it out together right now. So with reference to perimeter just means what is it all the way around, right? So how long is it all the way around your figure, right? So right now we have an irregular figure. We're not going to talk about the area, that's going to come later on. So for perimeter, for an irregular figure, you would just take all the sides and add them together. So I would have my P equals, and I'm just going to write it underneath. So my C plus B plus A plus E, and then plus D. And that is going to give me how long it is around the figure, which is my perimeter. All right, we're not going to talk about area. Like I said, we'll talk about that later for an irregular figure. So for a rectangle, our perimeter, right, we have 2 lengths, right? So how I would do perimeter is you can write it. So there's 2 ways to do it. So you can do perimeter equals length plus length, and then width plus width. Width. That's going to give me the perimeter all the way around. I can also write it as, because we have 2 lengths, right? So I can say perimeter equals 2 lengths plus 2 widths, right? So there's 2 lengths plus 2 widths. Or you can also rewrite it as perimeter equals, because there's 2 of them in each, we can do 2 plus, or times L plus width. Okay, so our area is always for a rectangle, is always our length times width. So I would write area equals length times width. Perfect. So for a parallelogram, I'm really glad that these actually have the names of these on them, because I blanked when I was looking at some of the figures. So for our perimeter, again, it's all the way around, right? So for our perimeter, we have 2 B's, right? So I can always write it as, I can do the exact same thing up here. So perimeter equals B plus B plus C and plus C, which I would end up with the same things that I can do up there. So perimeter equals 2B plus 2C, or 2B plus C. My area for this, it changes a little bit just because of the way it is. It's always like it's a rectangle and a diagonal almost. So my area would just be my base. So my base is this times my height. So my height is how tall this thing is, right? And that's going to give me the area. And guys, what area is, because I guess I explained what perimeter was, area is just how much space this actually takes up. So area is just inside here, how much space the figure actually takes up, okay? So for a triangle, our perimeter, again, is all the way around, right? So my perimeter would just be A plus B plus C. And my area for a triangle, we do area equals base times height, and then it's divided by 2. So for my trapezoid, we're going to have like my A plus my B plus my C plus my D for all the way around. So I would have A, I'm just going to do P equals A plus B plus C plus D. And for my area formula, we would have A equals, and I would put in a bracket, A plus B divided by 2, right? So my top and my bottom divided by 2, and then I would multiply that by the height. So height is found in the middle of it. And our last one we're going to talk about is our circle. So the perimeter around the circle is also called the circumference, right? How far around it is. Perimeter and circumference are the same for circle. So there's 2 ways that this can be written, right? So our circumference can equal, we always use pi for circles, so our lovely looking pi symbol. So pi, and we can times it by the diameter, and the diameter is all the way across the circle, so pi times d. Or if we're sometimes not given the diameter in the question and we're only given the radius, which the radius is from the center of the circle out to the edge, right? So it's half of the diameter. So I can rewrite this as 2 pi times r, right? Because we have r times 2, which is going to give you the same as the diameter. And so our area equation is area equals pi r squared. Okay, so I'm hoping you filled that out with me. If not, please find one that's actually useful to you or fill it out later, but these are going to be needed for this lesson and the next lesson. So we have some questions here that we're going to go over. So for example 2, I'm asking which shape has the greatest area, and we're going to go down and there's 3 different shapes, right? So I'm going to use my area equations. So for a circle, I'm going to slide back up here and take a look at what my area equation was. My area equation is pi r squared. So my area equals pi r squared, right? That's our equation. So the one thing that I need to input would be my r, right? And so my r is my radius, and my radius is always from the center of the circle to the edge. So my radius is equal to 8. And usually what I like to do first is I like to write my knowns and my unknowns beside it as well. But that's the only unknown that, or the only known that we have. So I can now figure out what my area is. So I go area is pi, plug in my 8 squared. Okay, and then sorry, I'm just flipping this around. So I would always do my 8, right? Because we're going back to bed mass, sorry. Back to bed mass, right? So what would I do first in this? Bed mass is always how I would end up doing equations. So do I have any brackets? Yes, I also have this exponent, right? So I would do 8 squared first. And so I would do my pi, and so my 8 squared is going to give me 64. Right, because 8 times 8 gives me 64. And then so I do pi times 64, which is going to give me 201.1. Because I don't know if this is centimeters or meters, I don't have anything after it because I don't think any of them have centimeters. So, but don't forget, if it does have centimeters or unit afterwards, you write it. So then now that I have my answer, I would box it, and we know the area of the circle. So now I'm going to slide down and do the area of my triangle, right? And so my area equation for my triangle is area equals base times height divided by 2. And then I'm going to write my knowns. So my base, right? My base is the bottom here. So my B equals 24. And my H, right? My height of this is 12. So I now take this information here and I plug it into my given equation. So I would put in my b, so my 24 times 12, all divided by 2. And so I would do the multiplication on the top first. So 24 times 12, which is going to give me 2 seconds here, 24 times 12, which is going to give me 288 divided by 2. And then 288 divided by 2 is going to give me, sorry, I'm just going to slide down a little bit, 144. So that is the area of my triangle. Now, because I want to, I'm actually going to give this some units. So I'm just going to say this was 8 centimeters. So then my area is going to be in centimeters squared. Okay, your area always has squared, because if you take a look at this, right, we are multiplying. So if this was centimeters too, and this was centimeters as well, 24 centimeters times centimeters is going to give me centimeters times centimeters, which is centimeters squared. Right, so we would have 144 centimeters squared. Okay, and now I have a rectangle. So the area equation for my rectangle is area equals my length times my width. Now my length, I'm just going to do it over here, is equal to 20, and we're going to say 20 centimeters, and my width is equal to 9, right? So I would do W equals 9 centimeters. And I can now take this information and plug it into my area equation. So my L is 20 centimeters, and my width is 9 centimeters. And this is what I mean. So we're timesing centimeters and centimeters, so that would be centimeters squared. So 9 times 20 is going to give me 180 centimeters squared. And so then the question had actually asked, which shape has the greatest area? So the circle has 201.1 centimeters squared for an area. The triangle has 144 centimeters squared, and the rectangle has 180 centimeters squared. So up here, we can see that this one actually has the greatest area. So I would do my therefore statement. Therefore, the shape that has the greatest area, hopefully you guys can actually read this, area is the circle. So don't forget, for word equations and stuff like that, we always need to remember the therefore statement. Okay? We have one other question for area. So I have an example 3. So a room measures 10 meters by 8 meters. How much will it cost to tile the room? That's supposed to say if it costs 1.15 square. Oh my goodness, $1.15 per square foot. Right. So what do we have to do first? What we have to do first. Sorry, I'm just moving some things around here. So what we have to do first is we have to, right, figure out what each of these sides, so I'm going to draw my little diagram first, and what each of these sides is in feet, right, because we need to know it in squared feet. So what we're going to do is we're going to have our 8 meters on this side, our 10 meters on this side, and to figure out how many feet are in a meter, right, what we have to do first of all is go take a look at our conversions. So my little step on it. I'm hoping that this is enough room, but we're gonna find out. So my little step 1 would be to go figure out what 8 meters and 10 meters are in feet. So for my conversions, I'm gonna slide back up here. Do we have meters to feet? So for 1 foot, it's 0.3048 meters. So then I'm going to take that conversion and slide back down here. And so I'm going to have, so for the first one, we'll start with 8 feet, right? So I'm going to do 8 meters times, and I'm going to put feet on the top because that's what we need. So for every, it was 1 foot, right? That's what we had found out. For every 1 foot, there's 0.348 meters in it, which equals, right, if I do the calculations up here, then I end up getting 26.24 feet. Right, so I'm just going to rewrite that up here. So for 8 feet, or for 8 meters, we have 26.248 here. And then we'll do the same thing. Sorry, same thing for 10 meters. So I would go 10 meters equals, or sorry, times, times 1 foot over 0.348 meters equals, and we get, sorry, 32.8 feet. I guess I should put a T on the end. And so then I would write this side, so 10 meters is also 32.8 feet. And this will allow us to figure out the cost a lot easier. So what we need to do now, right, we need to figure out the area because it's asking how much will it cost to tile the room that costs this much per square foot. So it's asking how much it will cost area-wise. So what we need to do here is use the area equation, right? So our area equation for a rectangle is always our length times our width. Right now we have our length in feet and our width in feet. So I would take my length, which is 32.8 feet, times our width, which is 26. Sorry, that's my phone. 26.24 feet. Right, we're going to multiply those together. So when we multiply those together, we get 860.67, and this would be in squared, like feet squared, which is square foot, right? So then I take this information, so I'm being really bad at boxing my information, right? But it's a little bit nicer when things are boxed. So now that I have how much this is going to, or how much space this is going to be, I can now figure out, sorry, I'm just going to put a little 2 here. I can now figure out how much it's going to cost. So what I'm going to do, right, so I'm going to do this as step 3, which is going to be my cost. So my step 3 would be to take the area times it by the cost per square foot, right? So I would take my 860.67 squared foot, so feet squared, and multiply it by my amount here, right? So I'll multiply it by my $1.15 because it's per square foot. So then these two cross out, and I end up with, so I would take my 860.67 times 1.15, which gives me $989.77. Beautiful. So then I would write my therefore statement, right? So it will cost, I'm just going to say it out loud, but this is my therefore statement. So I would have this as step 4. So I would have, therefore, it would cost $989.77 to tile the room, to tile the 10 by 8 meter room. Okay, hopefully that made sense to you. So we're just going to quickly go over last thing. I'm so sorry if this is taking a really long time. The last thing we're going to go over is the Pythagorean theorem. So this has to do with triangles. We're going to learn more about triangles later on, but I would like to recap on it right now before we get into it. So the Pythagorean theorem only works for right angle triangles, right? Which means that the one angle in this triangle has to be 90 degrees. So if we measured this, it would be 90 degrees. And usually it's represented by this tiny little square thing here. Sorry. So what the Pythagorean theorem tells us is that if we know two sides of a right angled triangle, this can only be used for right angled triangles, we can then figure out the third side, right? So what that means is if I know these two sides, I can now figure out how long this one is. But another thing that we need to note that I want to re-go over quickly is that the longest side of the triangle, right? This is always the longest side of the triangle, which is always opposite to the right angle. This is called the hypotenuse, right? And the hypotenuse is always the longest side, and we always have it as a length of quote unquote C, right? So in our Pythagorean theorem, right, if we're going to label this triangle, I'm just going to label this one A and this one B, we would write it as A squared plus B squared equals C squared. Okay? So I can now find the length of any third side. We might have to reorganize this if we're missing A. We would have to reorganize it, but this is always going to tell us that we can find a third side if we're given two of them. Okay? So let's go down to an example. I'm just going to go over two examples here. So determine the value of x. So what we know right now, right, is x is our hypotenuse. And the reason for that is because it's directly across from the right angle triangle. So I would label this side as my C. Okay, and then I can label the other two A and B. It does not matter which one is A and which one is B. So what we can see here is we're looking for C. So what I do for these questions is I'm going to write my knowns and my unknowns, right? That's going to be my first step one. So I'm going to write my A equals 6, my B equals 8, and my C equals X. So then from here, I'm going to write my equation. So I know that C squared equals A squared plus B squared. Okay, so I can now take this. I'm just going to change, I guess, to a different color as I'm clicking a bunch of things. So now I'm going to plug this information into my equation. So I'm going to do that as step 2. So my C squared is, we know C is X. So my X squared equals, my A is 6. So 6 squared plus my B is 8 plus 8 squared. So then I get X equals, so 6 squared gives me 36 plus 8 squared is 64. So then I can add those two together. Sorry, this should still be a squared here. So if I add these two together, I get 36 plus 64, which is going to give me 100. And then what I have to do to get rid of the squared on the x is I now have to square root both sides, right? So if I square root this side, x is by itself. And then I square root this side because whatever I do to the one side, I have to do the other. So 100 square rooted is going to give me 10. So the side that I'm missing, so length x, is going to be 10. Okay. So now we're going to go do one more practice question. I'm probably going to have to do some of it above here just because we do not have the button that I can push to extend it because it's under there. So now what we have here is we already know the hypotenuse, right? We already know what the longest side is. Let me just scroll here. So my very first thing I'm going to do is label my triangle, right? So I would label my hypotenuse because I know it's directly across from the 90 degrees. So I would label this as C. And then I can label my other two sides, it doesn't matter what. So I'm going to label this one as A and this one as B. Then I'm going to, for my step 1, put my knowns and my unknowns. So A equals 9, B equals X, and C equals 14. And then I'm going to, for my step 2, I'm going to just change to a different color. So my step 2, I would write out my equation, write my C squared equals A squared plus B squared. And then I'm going to plug my information in. So my C squared, my 14 squared equals, and then I have my A is 9, so I plug my 9 in, 9 squared plus, and then I have X squared, right, because my B is X. So what I'm going to do here, let me just grab my calculator, is I'm going to do, well, it won't let me go that route, 14 squared, so 14 squared is going to give me 196 equals, and then I have 9 squared. So I can do 9 squared, which gives me 81. I should know that one. Plus x squared. So what I have to do is I have to get x squared alone, right? So for me to get x squared alone, I have to get rid of this 81 here. And for me to get rid of that 81, what I have to do is I have to minus it from this side, right? Minus 81. And whatever I do to my right side, I now have to do to my left. So then I would go minus 81 on this side, right? So these two cross out. Let me just go back to, perfect. So then I'm going to do 196 minus 81, which is going to give me 115 equals x squared. And now I'm going to do the same thing I did up there. To get rid of my squared, I have to square root both sides. Right, so then 115 square rooted is going to give me 10.72 equals x. And that is going to be the length of B. Okay. So now what I want you guys to do is actually do some practice questions for me. So I have them posted up online for you. Because you don't have your textbooks, what I've done is I've actually scanned the textbook for you. So please go use what's up there. If you do have any questions, don't hesitate to contact me. Use your conversion charts, use whatever you need, and please reach out if you need help. Okay.